My name's Ben Cole, and this is physics. Oh!
The first one was
So, we fried the outlet. This outlet doesn't work anymore because we, yeah, don't worry about it. Alright, so we just got started working on this railgun. We went to Goodwill and we picked up a VCR and some stereo thing, and right now we're salvaging the capacitors because all the... It's not coming apart! Tristan is desolderizing the capacitors off the circuit boards right now. Nick is, that's a great question. This is a motor, and right now I'm taking the capacitor off the circuit board, and Nick's videoing right now, so. Right now we're taking these wires and we're soldering all these capacitors together to make a capacitor bank. Yeah, Tristan. So, yeah.
Dude, this thing is crazy, yo. It's freaking magnetic. Come look at this. This is the real stuff going on. It's like, you can't really see it. Look at that. Didn't you see that? Just kind of sticks on there.
Okay, so it is the second day that we're working on this railgun project, and before the boys come over, I picked up a couple of these because we need more capacitors. We don't have enough energy or electricity flowing through the coils to make it go as far and as fast as we want. So I picked up a few of these, and I'm going to go ahead and turn these apart to get the capacitors out.
Moving on.
Okay, now that I have this thing ripped open, you can see the capacitors. Very four large ones. There's 1, 2, 3, 4, and there's 2 over here and 2 right here. So now all I need to do is take all this stuff out, snip them out of the circuit board, and then I'll bring them downstairs to the basement and desolder them from the board. And you know what's cooler than salvaging these things for capacitors is you get a lot of cool CDs like the Brooklyn Tabernacle Choir soundtrack. Okay, so I'd like to take a few minutes to explain how a capacitor works. Now, all a capacitor is 2 pieces of conductive material separated by a piece of non-conductive material, or a dielectric. Now, these 2 outside darker pieces of wood represent the conductive material. It could be a piece of aluminum foil, anything like that. The middle lighter wood represents the dielectric, and all that does is it separates the 2 pieces of conductive material and prevents them from touching. Okay, so everybody else is downstairs working on the electronics for this thing. This is going to be our barrel. This is the coil we're going to use. We need a way to put the projectile in, so I'm going to using a drill, I'm going to cut out a hole or a little slot right here where I can put the nail in. So that's what I'm going to do right now.
Moving on and getting over, but not the friends they used to be. It's been so long.
What are you doing, Nick?
Moonwalk.
Alright, so we put the capacitors inside the magazine for our gun, and we're about ready to test it.
Right? It's on.
Dope.
We're good. That's all we need. We're set. Okay, so the basic principle of a railgun works is when you have a large amount of magnetic force in one specific location. In this case, it would be the coil. So if you were to have your projectile, pretend this is magnetic, in a copper coil like this, and you were to magnetize this or put electricity through it, the item would become, if you had it over here, it would become attracted to the center, but it still has its initial velocity, and the magnetism from the coil will pull it back, and it will oscillate in the middle like that. And what the reason we use capacitors is we want that short burst of electricity. So so the magnetic field of the coil pulls it towards the center, but shuts off while it's still being attracted to the center, and it just continues its velocity through the coil. Okay, so the capacitor bank is done. Basically what you do is you clip on the alligator clips for the positive here, the negative here, flip the switch to on, that allows power into the actual capacitor bank. And when you're done charging, hit the off button, and this thing's ready to fire when we get it connected to the gun. And right now Nick is wrapping the barrel with copper, and he's not too happy about it because it's going to take a long time.
This sucks.
Okay, so we just put everything in the gun that we need. This is our capacitor bank, which goes to the switch that we used to shoot the gun, and these go up to the front of the coil, which we put the bullet in right there. All right, so this is our final completed railgun. The way you charge the capacitors is you put the positive terminal on this coil, the negative terminal on this coil, flip the on switch to charge the capacitors. Keep this switch off though, so this is the trigger switch. So when that's done, you flip the off switch to prevent any leakage of the electricity from the capacitors. Then the positive wire is wired to this switch back up to the front where the coils are. The way you load it is you're going to put the nail right inside the top loader. You place, shoot. Uh-oh. Oh god. Okay, so you place the projectile up on the top, and you're ready to shoot it. So I'm gonna let Nick shoot it.
Yes.
Okay.
All right, here we go.
Hold it up. There you go.
Ready?
Yep.
And 3, 2, 1. Noise.
Hey.
Nice.
So that's our completed railgun. Took us all day to make. Cool.
There.
We're gonna stop.
Down.